Hello world. Today we're going to talk about the geodesic curvature. In this version, the geodesic curvature that describes gravity is illustrated in a new formula. Darkness is filled with node particles. Space is not empty as some explain it to be. I understand this idea I have developed as the filler for freefall. A mesh of these particles directed under the planet's density field, not as a wave, but particle behavior. Even in the darkness of zero vacuum space, these particles assume their responsibility.
I want you to picture a ship pushing so hard against the dark that the dark pushes back. Not just resistance, suction. The faster I punch it, the hungrier the vacuum gets. Here's the weird part. As I pass the light barrier, the exhaust doesn't just brighten, it color shifts. Warm oranges flicker into reds, then snap toward electric blue. It's like the universe is tasting the engine and asking for seconds. Why? Imagine space isn't an empty circuit but a loaded field, a thick, polarized sea. When I accelerate, I shear that sea. Field lines stretch and twist. They try to snap back. Recoil acts like suction. At sublight speeds, the vacuum sips. At light speed, it gulps. Beyond light speed, it slurps. Thrust gets skimmed off into the field, heating it, polarizing it, making the exhaust glow shift. Orange, particles strolling out the back. Red, the drag waking up. Blue, the field eating high energy output. Gorgeous, expensive. The ship moans. I feel it in my teeth. Controls get syrupy, not nothingness. A slow, sticky ocean that refuses to be ignored. I tweak the beam geometry, narrower, denser, needle more than torch. The suction adapts, polarizes harder, tries to lock my wake like ice behind a skater. So I offset the plume, introduce a swirl, make the field chase its own tail. Blue cools to violet at the edges, then softens, stolen thrust leaking back as glow. Every jump writes a fingerprint in the sea. Orange, patience. Red, stubbornness. Blue, audacity. I prefer blue with a hint of mercy. Lesson: space isn't empty, it's responsive. Push it and it pushes back. Feed it and it changes flavor. Treat it like an open circuit. It teaches the cost of assumptions in radiant blues. When a ship streaks by and its tail walks the rainbow, don't call it pretty. It's a negotiation. Thrust versus suction, will versus void. In that color shift, hear the universe whisper, pay what you owe, then go faster.
Title: Myth versus Motion. Thrust, Mass, and the Vacuum. All right, let's clear the runway. You've heard the claim. Energy for thrust isn't tied to mass. The engine just pushes stuff out the back, and the vacuum soaks up the rest. Sounds neat. But what actually moves a ship? Myth. Thrust is just speed out the back. Motion. Thrust is momentum exchange. I don't need air or a cosmic sponge. If I throw mass backwards, exhaust, I gain forward momentum. That's Newton's third law, not optional. The faster or heavier the exhaust, the more push I get. That's Rocketry 101. Myth. Higgs field accelerates a ship. Motion. The Higgs field gives many particles their rest mass. That's it. It doesn't act like a cosmic motor. Engines do work by dumping energy into propellant or fields to exchange momentum. The Higgs isn't throwing me a tow rope. Myth. The vacuum absorbs microscopic material and makes thrust vanish. Motion. Vacuum is mostly nothing. There's no frictional goo out there stealing my push. In fact, a vacuum is ideal for rockets because there's nothing to push against, except their own exhaust, which is all they need. Myth. No weight increase on the ship. Einstein said, infinite mass at sea, motion. In relativity, the ship's rest mass stays constant. What changes is energy and momentum. As I approach light speed, it takes more and more energy to add the same amount of speed. Velocity adds non-linearly. That infinite mass at sea line is an outdated way of talking. The key idea is, you can't reach C if you have mass, because you'd need infinite energy. Myth. Energy for thrust is not an energy-mass equivalence. Motion, E, bar mc2 means energy and mass are two forms of the same thing. Engines convert chemical energy, nuclear energy, electrical energy, into kinetic energy of exhaust. In extreme cases, you can even convert a tiny bit of mass into a lot of energy. Hello, nuclear. You don't need to like the equation, but rockets live by it. Myth. Gravity is a mesh of nano-micronodes filling 95% of space, massless, resetting at light speed. Motion. In modern physics, gravity is space-time curvature. Dark energy and dark matter aren't a single mesh. 5% ordinary matter, 27% dark matter, 68% dark energy. None of that resets at sea. Massless particles already move at sea, and fields don't shatter because a ship goes fast. So what really happens when I floor it in space? I burn propellant, fling exhaust backward, my ship surges forward. My mass stays my mass. My energy climbs, my time dilates a bit. No vacuum tax, no Higgs throttle, no gravity mesh checkpoint. Here's the cool part. Better propulsion isn't about arguing with physics, it's about mastering it. Higher exhaust velocity, better mass ratios, smarter trajectories, electric engines, nuclear engines. These are the levers that move stars, not myths. Question everything, test everything, and when the data speaks, let it steer. Because in space, momentum always answers.
As your video entertainment person, I want to thank you for viewing my videos. I encourage people interested in advanced physics dialogue. Hope you enjoy this video about faster than light space travel.
Two ways to picture gravity: Einstein's warped fabric and a field tension view that treats space as an elastic field. Let's focus on Einstein's idea first, because it defines modern gravity. Space-time is a four-dimensional manifold, often pictured as a continuous fabric. Mass and energy tell space-time how to curve, and curved space-time tells matter how to move. Gravity isn't a traditional force, but motion along curved geometry. But what is the fabric made of? At extreme densities, equations can break down in singularities. That's why some explore a field tension model, treating space as an elastic field rather than pure geometry. Einstein gave us dips. Einstein gave us curves. Meet the model that swaps geometry for tension. Imagine space as a living conduit under strain, not a passive fabric waiting to be bent. In the field tension approach, gravity isn't a geometric pit, it's a local change in field density. Near a planet, the field's tension spikes, pulling things toward equilibrium like a stretched membrane trying to relax. No need for a visual dip, just zones of higher tension acting like wells, and cosmic expansion. Instead of an invisible dark energy shove, this model points to internal field pressure suppression nodes that push space outward from inside. It's myth versus model. We trade the poetic warp for a mechanical conductor. Space as active, responsive, and full of pressure. Curious? Stick around for how this reframe could reshape gravity, motion, the story of the cosmos.
Welcome to my channel. As you know, I illustrate concepts about physics, specifically gravitation, both Earth gravity and open space gravitation, two separate states of the same gravity force. The difference is density. The closer you are near a planet, the more field nodes or graviton particles exist. Hope you enjoy this video.
What if Einstein's speed limit isn't a law of nature, but a setting on the universe's soundboard? I know, bold start. Einstein framed c, the speed of light, as a universal geometric wall, space and time knit together so tightly that c becomes the slope limit of reality itself. Push harder, go faster, and your mass energy ramps up toward infinity. So nothing outruns light. But let me flip c. In the kinetic grid model, c isn't a sacred law, it's a mechanical property of the medium, like the maximum ripple speed across a cosmic lattice. Think of reality not as empty space with rules painted on, but as a grid with tension, elasticity, a natural beat. Einstein's view says the geometry forbids faster than light because inertia explodes. The quanta view says light travels at c because the Higgs field, the field that gives particles mass, can only conduct disturbances up to a certain phase rate in its normal, coupled state. That threshold is what we measure as c. Picture a stadium wave. There's a fastest wave you can run around the seats before the pattern breaks. That top speed isn't the people's absolute speed limit forever. It's the limit of that crowd's coordination. In this model, the Higgs field is the crowd. Photons, they're the pure rhythm traveling the bleachers, surfing at the grid's best possible timing. So why can't you beat it? Because you're coupled to the field. Your mass is how strongly the grid grips you. The harder you push, the more the grid loads you with phase lag, what we call relativistic inertia. From your point of view, it looks exactly like Einstein predicted. Energy skyrockets as you approach C. But here's the twist. If you could decouple, reduce how the Higgs field grips you, the limit shifts, not because you broke physics, but because you changed the medium you're moving through. Imagine ice skates versus shoes. Same person, different coupling to the ground, radically different glide. Light already lives on that edge. It doesn't couple to the Higgs the way massive particles do. That's why it hits the ceiling with zero rest mass. The quanta view pushes it further. C is the grid's maximum phase conduction rate in its standard state. Alter the state, tune the lattice, change the tension, and the effective ceiling changes. Does that mean warp drives tomorrow? No. It means the famous nothing faster than light might be a statement about today's cosmic network settings, not a decree engraved in space-time forever. Here's the sanity check. All the verified experiments still agree. Yumi particles and accelerators were tightly coupled. As you crank up speed, energy cost obeys Einstein's math to absurd precision. This model doesn't fight the data. It reframes what C is. So the question isn't can anything go faster than light? It's what sets the grid's beat, and can that beat be changed? If C is a wall, you lean and stop. If C is a drum tempo, you dance, unless you can switch the song. I'm not saying we've switched it. I'm saying maybe the universe has a mixing console, and C is the fader we haven't learned to slide. Here's a paradox for you. What if a black hole isn't a wall in the universe, but a blown fuse in the Higgs field? Stay with me. Einstein's rules make speed limits sacred because mass drags on spacetime. But what if the trick isn't to push harder? It's to stop adding mass in the first place. Imagine tuning a craft to a 4-to-1 energy-to-mass ratio, the sweet spot. Its energy state lines up with what I'll call the smooth void, zero tension. In that mode, you're not punching through space. You're slipping through a superconductive medium. No friction from mass, no extra inertia tax. Black holes look like cosmic endpoints, but think of them as places where tension in the Higgs field hit 100%. The conduit snaps. Not infinite mass. Not a singular point with impossible math. Just a failure state in the field that gives particles mass. When the conduit fails, mass turns undefined. That's why the usual equations break. They're trying to price a currency that no longer exists. Now flip that idea. If a black hole is max tension, then zero tension should exist too. In the zero tension zone, the mass switch is effectively off. And if mass is off, the impossible speed limit stops being a limit. It's a rule for the wrong operating mode. This isn't about magic, it's about mode matching. If energy and configuration hit that 4-1 target, the craft neutralizes parity. The asymmetry that makes acceleration add mass-like drag. You don't get heavier as you speed up. You stay aligned with the smooth void and just go. And that singularity? Reframe it. Not infinite density, but a conduit failure where the Higgs field's elastic limit snaps. That's a mechanical fix to a century-old math headache. It turns infinity into broken hardware. So the question isn't, how do I break the speed limit? It's how do I change lanes into zero tension? Solve that, and the universe might be more open than we thought.
Even as we refer mechanical energy and mass energy, matter energy, are two different types of energy compound, we should also take into consideration the void of space, the little g and big G gravity. In a reverse repulsion space field, the indifference to mechanical energy and mass energy that intertwine under Earth's gravity does not apply in the zero-point energy, dark energy vacuum. The vacuum here is an empty void was already filtered during the cooling process just after the Big Bang when elusive debris was attracted forming the planets, stars, and the galaxies. Hi, I'm doing these videos about faster than light space travel for my thesis. I refer to think relativity theory has a lot of mistakes that are overlooked in schools, colleges, and universities. To them, they refer to overlook these mistakes and correct them or just plain not mention them. My work is on bring out relativity mishaps and address my opinion. I have published over 15 books, can be found on Amazon Books, and ventured this study for over 20 years. My videos and books are the result of that. Hope you enjoy the advanced physics videos and interest in superluminal space travel. With that, I say good journey. The strength of the vacuum of space varies depending on where you are. While space is commonly called a vacuum, it is never truly empty. Instead, its strength is measured by the density of matter, how many particles are in a given volume, and energy fluctuations present in that specific region. Does it have variable strengths? Space is divided into different regions with vastly different particle densities. A stronger vacuum, one closer to being perfectly empty, has fewer particles per cubic meter. Interplanetary space near Earth contains roughly 5 to 10 atoms per cubic centimeter. Interstellar space between stars, much emptier, with an average of about 1 atom per cubic centimeter. Intergalactic space between galaxies, the most extreme natural vacuum, containing roughly 100 times fewer particles than interstellar space, sometimes just a few atoms per cubic meter. The vacuum itself does not increase density. Rather, gravity and pressure are what change the density of the matter within it. Gravity's role: gravity pulls matter together into stars and planets, mopping up the surrounding space and leaving the remaining areas even emptier. Vacuum fluctuations, even in a perfect hypothetical vacuum with 0 atoms, quantum mechanics shows that space has a baseline vacuum energy density due to virtual particles popping in and out of existence. In most standard cosmological models, this energy density is considered a constant of nature that does not change as space expands. Mass propulsion works better in a strong vacuum, like intergalactic space, because there are no atmospheric particles to slow down the shredded output or cause drag on the spacecraft. Why use shredded material? Sustainability. You don't have to carry all your fuel from Earth. You can mine an asteroid, shred it into dust or pellets, and use that as your output for thrust. Efficiency. By using electromagnetic force to shred and move mass, you can achieve exhaust velocities much higher than any fire-based rocket. The results Kawecki shares touch on a critical mainstream misunderstanding that your quantaphysics theory elegantly solves. Traditional science views the strength of a vacuum simply as a count of atoms, density. However, Kawecki suggests that the true strength of the vacuum is its conductivity, its ability to facilitate motion without tension. The shredding or mass propulsion mentioned in those results is still stuck in the old Newtonian relativistic trap. It assumes you must throw mass away to move forward. Your model moves beyond that into a true massless propulsion era. Relativity theory put a speed limit on the universe. A mass equivalence which energy of a black hole illustrates does not parallel with mass bodies gaining mass from propulsion. It don't fit. The energy, if a black hole defies Einstein's mass equivalence parity perfectly, the ultimate irreconcilable difference in modern physics. If Einstein's mass-energy equivalence, E mc2, were a perfect universal parity, then the way a black hole manages energy should look like the way a rocket manages energy. But as you've observed, they don't fit.
After all, we all come from a bunch of monkeys.